Hey guys, welcome to part 3 of the Robot C basic tutorial videos. In this part we're going to start covering what Robot C is, how it works, how we can use some motors and servos in it, so we can get that going. So to start, Robot C is a pre-built compiler for microcontrollers, primarily NXT microcontrollers. And we already have some stuff set up, so I can just walk you guys through it. The first thing we have here is pragmas. Pragmas are your configuration code for motors or servos, and what we have here is we have the motor name, whether it's a motor or a servo, some configuration stuff, the name of it that you're going to be using in the code, and then down here it says encoder, and this is basically if you have an encoder on it or not, which will basically measure how far or measure the amount that the motor's been used on the robot. And that's easy because you can just go up to Robot, Motors and Sensor Setup, and then under Motors, the Motors tab, this is where you'll start doing it, and Robot C will do it automatically for you. You just name the motor, what type of motor it is, and I believe the port. I don't know exactly what these are for, because I don't have the NXT hooked up right now. So after the pragmas, you normally include includes. But since we don't have anything to include right now, we're just going to go straight to the main task. So we do task, main, and then put some parentheses, and then we put our two braces. So within the task main, this is where you start activating motors and everything. So let's go ahead and turn on motor. So let's just turn on motor, let's do back left. And let's turn it on to about 50 power. And let's do the same, let's copy that and put it below it and do the same for the back right motor. So what this code will do is this will turn the motors on to 50 power. The motors have a number from negative 125 to 125. Whoop. And 50 is going to be a positive, so it's going to turn forward. If it's a negative number, it will turn backwards. So keep that in mind when setting the motor's power. Right now we're turning it to 50, so they're both going to turn forward. And then after we turn the motors on, we only want them to be on for about 5 seconds. So we do wait 1 capital M sec, and then within that we put, let's put 5,000. That will be 5 seconds. So then after that, we can go ahead and turn these off. So we'll copy that over, and then we'll just set these back to 0, and they'll turn off. So basically all the code now is going to do is it's going to turn the motors on to 50 power, wait 5 seconds, it's going to go, so they're going to spin for 5 seconds, and then they're going to just stop. So that's good. It's simple, nice and simple. But we also have a servo, so let's go ahead and mess with that. So to activate that, what we're going to have to do is we're going to have to type in servo, and then again with the brackets, and then our name, which is serv1. And then servos work on a number from 0 to 180, depending on their position. So we're going to set this to 80, just for no reason. So right now what we have is the motors are going to turn at 50 power for 5 seconds, then they're going to stop, and then the servo is going to set into position 80. So that's pretty good. This is a pretty basic program, a very, very basic program for Robot C. And if you look up at the top, I have multiple tabs open up here, and up here are some more advanced stuff. So we'll take a look at the second one, and once again I have the same pragma set up, and then in our task we have, or I have it commented. Now commenting is very good to do in your code. It will make the code nice to look at, and it will help those that have no idea what code is understand the code. So right here we have turn both back motors onto 50 power. So we have that, and we're gonna go for 5 seconds. So say that these motors are attached to the wheels. The motors the wheels would go forward for 5 seconds at 50 power, which it's on a 0 to 125 scale, so it's about halfway. And then we're gonna turn. Say this is on wheels. We're gonna turn the wheels by setting one on reverse and one on forward. So the back left motor is going to turn backwards, while the back right motor is going to go forward, so it's going to turn left. Then we're going to also wait for it's going to be turning for 5 seconds. And then we're going to turn the servo to position at 100. So it's pretty much the exact same stuff as last time. Just commented, and we're turning now. Okay, and we have one more to look at, and this is for teleop. So, I don't have the servo pragma configured up here. So for teleop, you're going to want to include the joystickdriver.c file. This will allow you to use, this will connect the controllers to the robot, so you can use the controllers to drive the robot. Okay, and after that we have a function called stick controller, and this is basically going to take the data that we get from the joystick, and it's going to turn it into a scale that the motors and servos will actually understand. So since motors are on a scale from 128 to -128, we're gonna scale the number that we get from the joystick down to within that range, and that's basically all this is doing. The float before the function name is what it's going to return, so it's going to return a float, and within the parentheses we have the parameters, which is basically what's going to go into the function to give us that output. Within the main task here, we have the wait for start function, which is going to wait for the start of teleop. Then we have two ints, the threshold and threshold 1, and these are going to be for the joysticks. So when you're moving the joysticks, they usually don't set back into place at 0. They're usually going to be about 5 or -5 off. So that's why you want the threshold to make it so that if it's within that range of 0 to about 5, then it's going to turn off the motors. This is going to turn on the brake mode of the motors, so you want to set that to false. And then for teleop, you're going to want to put the entirety of the code in a while loop so that it will continue to run, and it won't just run once, and your robot won't just sit there like a giant pile of parts. So you're going to want to first get motor control from the joysticks, which is to get joystick settings from the joystick. And then you're going to want to set a float for the joysticks, for each of the joysticks. So one for the left and one for the right. And then you're going to want to set one for the second controller too. So what we have below that is, well, for this code we actually don't need the second controller. We just need the first one. But below that, what we have is that, so the absolute value, if the absolute value of joystick Y1, so this, is greater than the threshold, which we set up here, it's 5. So if it's greater than that, so or, this is or, the absolute value of joystick Y1 is less than threshold 1, which is basically the opposite, so covering both sides of the joystick. And then you have it same for Y2, absolute value of Y2. The second joystick or analog stick on the controller, and the opposite of the second analog stick on the controller. It says if it's greater than the threshold, then it will set the motors to whatever the joystick is set at. So that's this float up here. So we have the float set to whatever the value of joystick 1 is. So we're going to set the motors to whatever the value of joystick 1 is. And the stick controller right here, you can see the stick controller function. That's going to be basically turning the input from the joystick into something that's useful for the motor. So it's going to scale it down to that 0 to 125 range, 128 range. And then we're going to set both motors to that. So that's basically going to move the motors based on how far the joystick is forward or how far it is back. And then we have an else statement that if it's not any of these, then it's just going to set the motors to 0, and it's not going to do anything. And then after that, we have a wait function for about 5 milliseconds. And what this is going to do is it's going to give latency so that if there's any button input or anything, it will recognize it and it won't like cause any lag or anything with the controller inputs. It helps basically the code recognize the controller input. So that's about it. This is basic stuff for Teleop. So this is what the code's going to look like for a lot of Robot C programs that use the joysticks. So you guys, if you have any questions, make sure to leave a comment and we'll try our best to get back to you about how to fix a problem or whatever you need. And next time we'll talk about NXT and how to use it with Robot C.